Lesson 6.5 is equations containing radicals. So our goal is going to be to solve equations containing radicals. So for example, something like you see here, 40 equals the square root of 22d. So an equation like that that has a radical in it, first of all, that's called a radical equation. That makes sense. And then you can read here how to solve one. It says to solve a radical equation including square roots, start by isolating the radical term. So that's always the first step. On one side of the equation, then square both sides of the equation. So you'll square it if it's a square root, but if it's a cube root, then you'll be raising each side of the equation to the third power. So that's the game plan. Let's go ahead and see some examples. So here we go. We have an equation that contains a radical. The first step is to isolate the radical on one side of the equation. That's already done for us. We have a square root of 3x plus 1 on the left-hand side and nothing else. We're not adding anything after that radical, or we're not multiplying anything to it, so it's already isolated. So the second step then is to square both sides, because that allows us to get rid of the square root on the left-hand side there. Because if I square a square root, those are inverse operations, so I'll just be left with 3x plus 1 on the left-hand side. And then 7 squared is 49. Now we just have a basic linear equation to solve where we'll want to isolate x. So I could subtract 1 from both sides and I'll get 3x equals 48, or x equals 48 over 3, so x equals 16. We do want to do a check for these problems to make sure when we plug our solution back in that we get a valid statement. So I would just quickly check that 3 times 16 plus 1 equals 7, which yes it does. So solution checks and the correct answer is x equals 16. Okay, example 2, same directions. We're just going to solve this radical equation. So step 1 is always to isolate the radical first on one side of the equation. So we have the square root of 2x plus 5, but that's not isolated. There's also this minus 1 on that side of the equation. So what we need to do is add 1 to both sides. So now our square root is isolated. Step 2 then, the inverse of taking the square root of something is to square it. Whatever you do to one side of an equation, you have to do to the other. So on the left-hand side, we'll be left with 2x plus 5. But on the right-hand side, we have x plus 1 times x plus 1, since it's x plus 1 squared. So really on the right-hand side there, we're going to have to do some distribution. So I have 2x plus 5 equals x squared. If I use my inner and outer terms, that's going to be plus 2x. And then 1 times 1 is 1. So now I notice I have a quadratic left over. So I'm going to have to get this equation equal to 0 and factor and solve. So let's get this equal to 0. First I'll subtract 2x from both sides. So I get 5 equals x squared plus 1. If I subtract 5 from both sides, I'm going to get 0 equals x squared minus 4. So that factors into x plus 2, x minus 2. So setting each factor equal to 0 gives us x equals negative 2 and x equals 2. Again, we're going to need to check our solutions to make sure we have a valid statement here. So I'll go ahead and do that up here. Check. So if I plug in, let's start with 2. I'm going to have the square root of 2 times 2 plus 5 minus 1. We'll make sure that that equals 2. And it does, because the square root of 9 is 3 minus 1 equals 2. So x equals 2 is definitely a solution. So then the next thing we'll do is check negative 2. So if I do the square root of 2 times negative 2 plus 5 minus 1, we're checking to see if that's equal to negative 2. So under the square root, I'm going to get 1 And now we can see that this doesn't work because the square root of 1 minus 1 is just going to be 0, which does not equal negative 2. So that's not a solution. That's extraneous, and the only solution to this equation is 2. All right, here's another. 3 times the square root of x equals 12. Step number 1 is always to isolate the radical. So we have this square root of x being multiplied by 3. So the inverse of that is to divide by 3 on both sides. So we get the square root of x equals 4. Now that the square root's isolated, we can go ahead and square both sides of the equation. So we're going to get x equals 16. We got to remember to do a quick check here, just to make sure that 3 times the square root of 16 is equal to 12, which, yes, 3 times 4 does equal 12, so x equals 16 is a solution. So I'm just going to do this equation just to make sure that you notice the difference between this example and the one before it. This actually isn't a radical equation. This is just our variable x is not under a radical. So this is a linear equation. We would just want to get the x by itself in this problem. So I would divide by the square root of 3 on both sides and get that x is 12 over root 3. Well, now you know that we can't leave radicals in the denominator, so I could quickly rationalize this by multiplying by root 3 over root 3, and I'll get 12 root 3 over 3, or 4 root 3. So in this case, I didn't have to square both sides of the equation because the variable wasn't underneath a radical. So just be careful making sure you notice the difference between example 3 and example 4. Alrighty, here's a good example. Example 5, we're taking the square root of x plus the square root of x minus 7 equals 7. So you see there's a radical in 2 places. So you still need to isolate a radical on one side of the equation. You can pick either one to isolate, though. You just need to get one by itself. So let's say I'm going to try to get the square root of x minus 7 by itself. If I'm going to have that by itself on the left-hand side of the equation, I need to subtract my root x from both sides. Now I can go ahead and square both sides of the equation. That's going to get rid of the square root on the left-hand side. I'll have x minus 7. But on the right-hand side, I'm going to have to do some distribution here. So we have x minus 7 equals 7 times 7 is 49. My inner term is minus 7 root x. My outer term is also minus 7 root x. If I multiply the last 2 terms together, I get plus x. Okay? So let's combine some like terms here. So I have x minus 7 equals 49 minus 14 root x. Those are like terms. Plus x. I can see if I subtract x from both sides of the equations, that will subtract to 0. So I get negative 7 is 49 minus 14 root x. Now, basically what's happened at this point is that there's still a radical in this equation. So we need to do the same thing that we did before. We need to isolate that radical and then square both sides. So that's my goal right now, is to get that square root of x by itself on the right-hand side. So let's go ahead and isolate our square root of x, like I said. One little trick that I'm going to do here, just to make my math a little bit easier, I like to go ahead and just divide everything by 7, because I can see that 7, 49, and 14 are all divisible by 7. So I get negative 1 equals 7 minus 2 root x. That's not required for you to do that step. It just is going to make your math a little bit easier. So now if I subtract 7 from both sides, I get negative 8 is negative 2 root x. I'm going to need to divide by negative 2 on both sides to get the square root of x by itself. So I get 4 is the square root of x. Now I'm to the point where I can go ahead and square both sides of that equation. So what I'm going to be left with is x equals 16. Don't forget to do a quick check in the end here. I'll just do it right down here. Check. So we need to make sure that the square root of 16 plus the square root of 16 minus 7 equals 7. Yep, okay, so square root of 16, we get 4. Here we get this plus the square root of 9, which is going to be 3, and 4 plus 3 does equal 7. So the correct answer to this one is x equals 16. Try to get it all on the screen there. There we go. Okay, last example here, we need to do one with a cube root. The idea is the same, that we want to isolate a cube root on one side of the equation, and then we want to go ahead and cube both sides. So in this case, we have a cube root on both sides of the equation. So one being already isolated on the right-hand side. So let me say this is my isolated side, the right-hand side. So I'm going to go ahead and cube both sides. Because cubing a cube root, those are inverses. And on the left-hand side, we'll just be left with x minus 7. So we got rid of that cube root. Now on the right-hand side, we have to deal with the cube root of x over 2 cubed. Well, our rule of exponents then tells us that we cube the numerator and cube the denominator. So we know the cube root of x cubed is just going to be x, and 2 cubed is 8. And now we have an equation where we just need to go ahead and solve for x and then check our work. I'm going to multiply the equation by 8 on both sides to get rid of that 8. So I'm going to be left with x, because these cancel, equals 8x minus 56. Now if I get all the x's together, I can subtract 8x from both sides to get negative 7x equals negative 56. Divide by negative 7 on both sides and get x is 8. Don't forget to do your quick check. So we got to make sure the cube root of 8 over 2 is equivalent to the cube root of 8 minus 7. Move the screen up a little. There we go. So the cube root of 8 is 2. So 2 over 2 we're making sure is equal to the cube root of 1. This is 1 equals 1. So the correct answer is x equals 8. There we go. All right, that's going to be it for today. So go ahead and check Schoology for homework.